Hi, this video is just going through some slides and probably a quick demonstration around technologies for measuring potassium. And I want to say in the sweat, but many of our sensors at ZP don't really mind whether what the sample really is. I should be very careful with that statement, but you know, urine, blood, etc. But what I want to do is just say that this is not just talk. I've got some technology in front of me now, so I will be doing a quick demonstration. With that said, let me jump back to the slides. So the main focus is potassium on the sweat. I think this discussion could also equally extend to sodium as well. These are very kind of matured sensors that we have at ZP. I'll also put some slides underneath this video as well, just to say that a potassium sensor does exist at ZP. We do have a data sheet on it, and I will be putting a link underneath this video to that data sheet. And also, if you're getting a potassium sensor from ZP, I will also say that there's some test solutions that you can also get, and I'll also put a video underneath this link as well. The reason I put a definite link to the data sheet is if you have any kind of questions, the answer is in the public domain. Otherwise, people can engage us in a sort of deep program, you know, paid for program where we can get a lot deeper into this. I'd probably go quite quickly on this, but just to kind of say that people are interested in the selectivity of sensors. And I haven't done the calculation for sodium, but I have done it for potassium. Just to kind of say that our potassium sensor, one of the closest ions to potassium, for example, is sodium, and they can coexist, especially in human type samples. So people are interested in what's the response to sodium versus the response to potassium. It's probably worth saying that the potassium sensor, the ionophore, is quite sensitive relative to sodium. It's 2,500 times more sensitive. This really means that when we consider the kind of concentrations of sodium and potassium ions in things like sweat or urine, I want to say blood, then even if you times these sort of relative selectivities by the concentrations, you find out that really the sodium is only making something like a 1% contribution to the total potassium signal. So it's essentially hardly anything. Now, even though I'm about to talk about wearable sensors, I will also demonstrate that sort of a point of care, point of need type testing is also possible with these types of sensors as well. With that said, let me go forward and just say, you know, at ZP, we're very committed to testing sensors. Now, these are not potassium sensors, but these photographs are also not old. I'm making this video on the 23rd of December 2024. Happy holidays. And it's worth saying that this image is about just really less than 2 weeks old. It's just to show you that we actually are putting sweat sensors onto people and, you know, doing testing as well. So ZP, we are ISO 13485, which means contract development, contract manufacturing of medical devices and diagnostics, and, you know, including, you know, testing on humans, for example, which we are doing here. So there's 4 sensors being tested in parallel, and you know, we're even sort of shifting them around different parts of the body to kind of, you know, find out, let's say, the optimum place. And I have a couple of the close-ups of these sensors here. It's probably worth saying as well that many people do have electronics already. If you don't have electronics, ZP does have a wearable electronic set. I'm not a great believer in splitting the teams. You know, a team that does the sensor and a team that do the electronics. You've got these 2 teams. These 2 teams essentially have to kind of coexist because they essentially need each other. So it is, I think it's sometimes a little bit risk. It can be a risk to have my electronics developed here and my sensors developed here, and then sort of bring these 2 things together. To be in the world of potassium and sodium sensors, when you're using a potentiometric mode, I would actually say that risk is less. It's things like amperometric modes, things like glucose, lactate, ketones, that I would say that the risk is higher. But I'll be straight with potentiometric type sensors. I do think that risk is less because it's, you know, it's not that hard to make essentially a a voltage reader, high impedance voltage reader. I'm just going to do a quick demonstration. The reason I'm going to do this demonstration is I really want to talk about the technology stack that we have at ZP. I think we've really diminished the time it takes to get to market. So what I'm going to do is I have a Sense It All platform here. Sense It All really is a technology stack that we have at Zimmer and Peacock. So what I'm going to do is I've got a series of QR codes in front of me, so we can drive our electronics, be them wearables or be them point of care diagnostic, amperometry, open circuit potentiometry, different QR codes. We can read those QR codes and set the app. This app, by the way, is downloadable it's called Sense It All, and you can find it on the Apple App Store. You can find it on the Google Play Store. I'm in open circuit potentiometry mode at the moment. What I'm doing is I'm just going to put a new sensor onto there. So this as a point of care diagnostic hardware is really kind of nice because it really gives a very nice user experience. I'll close that up now. I will put essentially a sort of blank solution on there, if I can call it that. So let me just put a blank solution on. The nice thing, the reason I'm going to do the experiment this way is because it kind of demonstrates, it's very clear to see the kind of signal response. So let me put that on like that. And let me think very carefully. I just want to give this a name so I can find the data later on, which I've now done. I'll go continue and I will start the measurement. So what's happening now is my app has told essentially the meter what to do. The meter is essentially running that test in a minute, or not in a minute because I'm going to do this test in less than a minute. What I'm going to do is I'm just going to add a redox active molecule so that I can sort of show you what I'm trying to demonstrate is the technology stack. So now what I'll do is I'll add this in. And you can kind of see the very fast response, which is not super surprising, let's say. So I have a baseline, now I have a sort of a response to the analyte. I'll just let that run. And then at the end of this, I'm going to demonstrate to you essentially what happens next. And I realize, maybe I've got something here. I may do a quick demonstration to you, an extra demonstration to you as well. I wasn't necessarily planning to do that demonstration, but in fact I will do that demonstration as well. So what that does then, it finishes the analysis and it uploads the data to our cloud system. But bear with me because I'm actually going to do it may not be the world's best demo what I'm about to do, but I do have a second demo to come as well. So I just want to kind of show you the utility of this platform, how sort of powerful it is. So what happens now is if I just go to my screen to here, then I can, so my app has just changed its status. So it now says upload complete. And then if I just do a quick refresh here, then it will it'll basically show me the most recent data, which is here, and then I can have a quick look into there, and I can see. So this is very powerful when you're doing essentially clinical trials or doing things remotely, because all the data is gone to the cloud. Now I wasn't planning to do the next piece, but I'm actually going to do another demonstration now because I just want to show you that this platform is designed to get people into a real product as quickly as possible. So bear with me while I just do this second demonstration. So what I'm going to now do is I'm just going to show you the power of this device. So I just did a very sort of scientific experiment there. What I want to do is I've scanned a different QR code and I've basically gone into a different test, but I just want to kind of show you the kind of user experience that we're working on. Now I just grabbed a sample, so I hope I grabbed the right sample. It was a bit of a spontaneous decision. I just grabbed it there. I'll just call this tab 33 so I can find it in a bit. And what I will do is, in fact I need to get a new sensor, so I'll take that sensor out. Let me just grab a new type of sensor. This one's got certain specificity built into it. So I've got the sensor now. put that sensor in there, close that off. And I will take this sample. The nice thing about electrochemistry as a science, if you're dealing with dirty samples like blood or urine, you can see this is not the cleanest sample ever. But what I will do is just put the sample on. Sample's now on. I will go continue. I'll go start. And I'm running a very different type of assay now. I'm actually now running earlier I was running a potentiometric assay, now I'm running a voltammetric assay. It may not be the best because this sample was just like I spontaneously grabbed, but I've got a result on my phone. Now the reason I showed this one is because this one, we've taken it a little bit further now, this assay, and it's actually given us the micromolar concentration, 280 micromolar. So here we're giving a much more sort of user experience. But again, I just want to share my screen with you. The data has actually gone up to the cloud. So I still have this advantage of this back-end cloud, and I can see the data here. Except with this one, we've really taken advantage of something that we call our data pipe, where I've actually taken the signal, pre-processed the signal, found the peak height in this particular case, and turned it into concentration. And so this back-end has a very powerful way of processing data. We can filter, we can do what's called pre-processing, we can tell the data where to tell the cloud system where to find the signal, tell it what, if we use the dilution factor, what to do, etc. So there's a lot of, this back-end cloud system called Julie has had 10 years chronological effort put into it. Tens of thousands of man hours have gone into it as well. So if I was just to start to summarize this, so I did a quick one on OCP, or quick demo on OCP, open circuit potentiometry, but the ZP potentiostats, so we have these electronics, we have sensors that go with these electronics, we have the ability to put samples in either through the sweat patch or just through the pipetting that I just showed. We have QR codes which tell our app what to do. Sometimes it's just the scientific experiment, but sometimes it's actually more analyte specific. The app tells the meter what to do, the meter does the work, or the electronics does the work and sends the data back. And then actually we can send the data to a cloud system called Julie, where we can do all sorts of processing on it and actually send a number back essentially to somebody's smart device. It's probably worth saying that the cloud also has an API, an application program interface built in. The whole idea of this technology stack really is to get people to something like a minimally viable prototype as quickly as possible. Otherwise, it could be taking some years. If you do have any questions about potassium measurement in sweat, or really just electrochemical biosensors, both point of care or wearables in general, please don't hesitate to contact us. Okay, thanks very much.